Okay, so today, the first thing I got to teach you is something really pretty easy. See how that says 84 degrees? Tangent of 84, you could type that in your sleep. Super easy, right? But what about the 84 and the 24? What do you think that 24 means? It's got a little hash mark. You know what that means? 24. Yeah, feet is a good assumption. That is, in a different context, one dash like that means feet. Different context, though. 24 minutes, that's correct. If you ever dealt with nautical stuff, you might understand more about what this means. I'm just going to do the quick, super easy conversion for you to show you. You go like this. It's really 84 and a little bit more. Wouldn't it have been awesome if they just said 84.36? Like make it a decimal? Well, you can make it a decimal because it's 24, and think about it. It's kind of intuitive. If it's 24 minutes, what do you think? It's 24 out of 60. See? That's all there is to it. And do you get how you can make that a decimal really easy? By saying 84 plus parentheses, probably. Otherwise, you might screw up the order of operations. And then you'll have a decimal. Would you try typing that in right now? You're going to need a calculator. If you want to borrow one, come on up and leave me some collateral, like a cell phone, your keys, whatever. I'll give you a calc. Don't just sit there. If you don't have your calculator, come up and borrow one. Pause for a second. Okay. Next thing. Some of you are in radians. My prediction, 6 of you, just totally making this up, but I bet you it's close, are in radian mode and don't know it. Would you hit mode, please? Hit mode. How many of you discovered that you were actually in radian mode? 1, 2, 3, 4, 5, 6, 7, 8. Dang it. Okay, well, that's close. You see how that could screw you up on an ACT test? You thought you just typed in tangent of 84, but you did tangent of 84 radians. That's totally different than degrees. A radian is about 59 degrees each. Okay, so yeah, that's totally different. So anyway, bottom line, get into degree mode. Then type in tangent of 84, and then this is some decimal. 84 point something. And I think it's 84.4. That sounds correct. So then, if it's 84.4, what is tangent of 84.4? I know it doesn't mean much to you right the second out of any context, but yes. I would use degree mode all the time. When you hit calculus, you'll be so good at radians by then that starting in calculus class, you'll probably start defaulting to radians. And usually then, when you type in a degree, you either change it to radians in your head first, or there's a special little degree symbol you can use. So bottom line, this whole year, use degrees. On your calculator, that is. We'll be learning about radians a lot in the next few days. All right, so this one is a little obscure, and I want to show you like some context for it. So if I had a triangle, you get there's a triangle called the 3, 4, 5 triangle, right? Could you believe that there could be a right triangle with that being 3 and that being 5? Does that sound believable? Okay. Then, and I know you know this other one's 4, but let's not use the 4 just because it'll actually make it more complicated. I don't know what that angle is. And you probably don't know it either because it's not a 30, 60, 90. So it's some degree. I don't know what it is. How can you figure it out? Last hour, there was 8 kids that could do it without any assistance. I want to see which of the 8 kids that already know this coming in. If you don't know, it's totally okay. I didn't expect 8 people to know it. I only thought 2 people would know it. If you know how to figure out that angle right there between the 5 and the 3, do it. If you don't know, it's okay. I'm going to show you. How many of you think you got a shot at this? All right. It's like 4 or 5. All right. Here's what they should have done if they did it right. They should have been thinking in terms of sine, cosine, and tangent. And would you agree that from this angle's perspective, it has the adjacent to this angle and it has the hypotenuse? Which of the SOHCAHTOA uses adjacent and hypotenuse? Cosine. But you don't just go cosine of 5 or something like that. You go cosine of some angle is, cosine is adjacent over hypotenuse 3/5. And some of you are like, no, that's not how you do it. I'm not done yet. Would you agree cosine of some angle is 3/5? That's an important skill to get too. Cosine of this angle is pa, adjacent over hypotenuse. Are you with me so far? Then to solve it and get theta alone, I'm going to do inverse cosine. Because inverse cosine cancels off cosine. It's kind of like times cancels off divide. You know, they're opposites of each other like that. Theta will be inverse cosine. I'm going to write this clearer now. Cosine with a little minus 1 of 3/5. You type that into your calculator. 3/5 you could just change to a decimal in your head quick. Can you change that to tenths quick in your head? To be 6/10 to be like 0.6. See what I mean? So then you go inverse cosine of 0.6. That's a little quicker. And it will give you some number of degrees. Can you tell me, Miss JS, what did you get for the degrees? 53, I'll just stop right there. 53.1 degrees. Raise your hand if you had that. Okay, cool. Let's see if that's stuck. Here's a new problem. What's angle theta? Which one's the right angle? I suppose I should label that. Should I use sine? Should I use tangent? Should I use cosine? So some function, let's say it was tangent, would be opposite. Ooh, I don't have the opposite, so I better not use tangent. That's kind of how I would think it through. This is a great process, but it's long because you got to write out SOHCAHTOA. And you ask yourself, okay, it's got what and what? Would you agree this one's got adjacent and hypotenuse again? So it's a cosine one again. So then I'd say cosine of some angle is 12 over 13. Then to solve it, you do inverse cosine of 12/13. I like to show you why you do inverse cosine instead of just doing it. That is canceling that. Inverse cosine of 12/13. Do you get how that actually could work in the real world? I want you to think about that for a second. You're building something. Like, say I was building something in this room. And I had these, I didn't have a way to measure the angle. Like, I didn't have a protractor with me. But I could measure how long this board is. And I could measure how long that board is. And then I could just go to my calculator and figure out exactly what that angle must be. See what I mean? All right. Okay. By the way, what was it? Like 20 degrees? 20 degrees? On 2.6, I think I heard. All right. Okay, good. I think you get how to do that part. So that's just a couple little things to warm up. If I had said this, I hope you'd be able to go, oh, so you go inverse cosine to solve that. That'll make this cancel. Inverse cosine of 4/9, and you could have got your answer. Now, in degrees and minutes, I'm okay with you just giving your answer as, 28.3 degrees. If you wanted to change that to degrees and minutes, I don't think we would test you on that, but you'd need to take 0.3 and get it to change into something over 60. Now, it wouldn't be that hard. And again, I don't think we're going to test you on it, so I'm going to blow past it for now. All right, so what's the typical question for today? If I just asked you to do this, would you be able to? All right, I'm not going to. I think you should be able to. If I just asked you to solve that, could you do inverse cosine and solve it? All right, good. Then let's talk about this. So far, I've been reminding you that you need to pull out the triangles because there's a double triangle here. This is overlapping triangles. And I'm going to pull out the outside one, the bigger one. You don't always have to make them the same size or anything. And I'm going to label what I got. I got 2100 here, and I got 1200 here. And I don't know this angle right here. That's the one that they're calling out. There is 3 angles, of course. They apparently want to know this one. Do you get how you could use what we just talked about to find that angle? All right. So you just use inverse probably. Let's see. We got adjacent hypotenuse, inverse cosine. Okay, good enough. Let's say we have this. Do you remember your ratios? 30, 60, 90, 45, 45, 90? You still do these. We did them on the first day. Take a second. This one's a little too easy, so do this one. If I were you, I'd make a little helper triangle next to it. Solve it. Hopefully you got those 30, 60, 90 and 45, 45, 90s memorized. Drawings are not to scale, so you need to label those things. 1, 2, square root, 3. And then, which side do we want? Well, it doesn't matter. You got to find them both. So why don't we pick this and call it H? Could have called it C. That'd have been another good choice. I'm going to say H is to 2 as 22 is to root 3. And then I'm hoping by now I've convinced you that cross multiplying is not the best way to go. It takes 2 more steps. I can do this in 1 step. Times 2 times 2, I'm done. 44 over root 3. That's the hypotenuse. Some of you might have solved for the other side. Well, that's a different answer, of course. Find that one, you just set up a different proportion. I'm going to call that one A. And I'll say A is to 1. Well, that's really awesome because A divided by 1 is just A. A is to 1 as 22 is to root 3. So that means A is 22 over root 3. Remember yesterday that sometimes the answer keys or the book problems are going to do that to it. So it's going to multiply by root 3 over root 3. It'll be 22 root 3 over root 9, which is 3. Same thing, same answer. Happens in the ACT all the time. Kids get the answer and they're like, but it's not there. But it is there. They just don't know that little trick. Okay, I think that's good enough. Remember these? We just had one like that, like yesterday. Remember how there's triangles inside triangles? I don't want to do all of these because it's going to burn up all of our homework time, but we did some triangles in triangles. So what's new for today? Actually, add a page at this point. I'm going to show you another way to do these besides setting up 2 triangles and using proportions. Let me show you what I mean. Let's say I say that's 30 and this side's 11 root 3 or something weird like that. And they want to know how long is A. You can definitely do it by setting up the proportions, drawing the helper triangle next to it. But I want to move you up to the next level. 12 minutes left, so I'm hoping to get you into your homework soon. The next level kind of question goes like this. What do I have from the angle 30? I have the opposite and I have the hypotenuse. So couldn't I say sine of 30 is equal to A over 11 root 3? If that's not easy for you, we need to get it so it is easy for you. And then you can still use your little helper triangle, but you use it in a different way. You go over off to the side and you say 1, 2, root 3, and you say, what's sine of 30 by looking at this? See, by having this triangle memorized, you can say, oh, sine of 30, that's opposite over hypotenuse. It's 1/2. Sine of 30 is 1/2. And that's how you can get your little proportion. Now, you might be saying, well, I like the other way better. What if I change it to 29 degrees? Will your little 30, 60, 90 work for you anymore? No. But will this still work? Yes. Do you get what I'm saying? Okay, so let me show you one like that. It's no longer 30. It's 29 degrees. So you can't use your 30, 60, 90 thing. And I want this side this time. I'm going to call it A. And I need one side and one angle. So I'll know this side is going to be 14. Can you set up the trig equation that would solve that? Hint, sine, cosine, or tangent of 29 is equal to something with the A and the 14. So figure out sine, cosine, or tangent first. Hint, I have opposite and adjacent. Which one is that then? There's only one function that uses opposite and adjacent. What is it? Sorry, I'm wrong. It's not opposite and adjacent. Sorry, it's opposite and what? Hypotenuse. Sorry about that. So which function has opposite and hypotenuse? So then you have to use sine. Sine of, well, there's only one angle. Well, I mean, there's 90, but you don't ever use the 90s. All right, sine of 29 is a over 14. This is a really important step because from here, it's super easy. You could teach a 6-year-old how to type in sine 29, enter. You know, it's just it's easy. You just get a decimal for it. By the way, it's point something, 0.4 or something. What? 48? 48 is good enough. And then I can multiply by 14 on both sides and it's done. That's a pretty good way to do it. Nice part. You don't have to have any triangle memorized. I hope you have the triangles memorized because they are going to come in handy in other places too. But if you have a calculator, this is a pretty slick way to do it. Let's do one more like that. That's 12. This is n. And this is a 17-degree angle. Sine, cosine, or tangent of 17 equals something over something. This is super important. Don't drift on me. I know it's Friday. I need you with me. Okay, should have said tangent this time. Why? Because there's no hypotenuse. If you look through SOHCAHTOA, if you don't have the hypotenuse, tangent's the only thing you can use. Because it uses opposite and adjacent. And I have opposite and I have adjacent. Okay, so tangent of 17, that's where the angle always goes, equals TOA, opposite over adjacent. I sometimes use this just to remind myself. And so then, what is the opposite? Is n over 12. There we go. And then tangent of 17, just type it in, get a decimal, easy. And then multiply both sides by 12. Would you agree that it'd even be more accurate if I just cleared the fraction and said this? My answer's 12 tangent of 17. Because actually that's better, because why? Because it's not rounded. See what I mean? If you got a decimal for tangent of 17, you probably have to round it. Unless it happens to come out perfect, which is rare. Okay, I think you know everything. Let's look at your homework. Right there, this one. So we're going to do, this is two separate problems. They aren't great at numbering here. This one's B and this one's D. Notice this top one, you might be like, wait a minute, this is the first one where we don't have a right angle, right triangle. So make one. On all the problems today, you can make things that don't have right triangles have right triangles with a strategic line. Like that one. Do you get I just made a 45 and this is 90 and therefore the other one must be 45? I just made a 45, 45, 90 on the end there. See what I mean? And if this is 45 and this is 90, then that one in there, this little angle there, that must be 45. And if the whole thing was 105, you can pretty quickly deduce that that one must be 60, because to total 105, that's how it would have to be. And now I've got a 30, 60, 90 over here. Isn't that cool? Okay, so the point is, you're going to put in some lines, and you'll end up making right triangles where you didn't have right triangles. And then you can pull out, as I've told you before, pull out the little triangle, because that's so messy. Pull it off to the side and see what you know. I know this is 45. I know this is 90. Oh, that must be 45. And I don't have any sides. What does that tell me? Then that's not the triangle you should use first. If you don't have any sides, you can't do anything with it. Then pull out the other triangle, this triangle. Do I have any sides of that? Oh, yes, I do. I have a 10 here. And this is 60. And that must be a 30, 60, 90 with the 10. I can deal with that. And then I can find Well, how does that help me with this triangle? Because they share a side. This side here is the same as this side here. And once you find this side, you now have a side on your green triangle. All right, so that's the general process you use. Do those two. You may you do this one. You may skip both of these. I don't like them. You're not ready for that yet. And do these, but then stop. You can draw a line underneath this. You can skip everything underneath it. That's a reasonably sized assignment. Definitely doable. You have a key, for Pete's sakes. There is no reason why you couldn't have this done on Monday. Okay? So, if you haven't already, please Dropbox that top 20 that we finished up and graded. Take a screenshot of it, Dropbox it. That's just your first attempt. We will take the top 20 again, and it's going to go in the 85%, or wait, in this class, yeah, it's 85. In the 85% in the testing category. That will go in the testing category, but you're going to get a couple weeks first to get better at it. Some of you could take it today and be awesome, but some of you need some time to brush up. I strongly recommend making major improvements if you're one of those kids that had like 8 things you didn't know. And that's all I have for you for today.